Hello all and welcome to the first video for our cyber instruction. So here you can see the do now would have been reflect on the previous test, but hey, national emergency, we weren't able to have a test. So here what we have, section 9.1 is the next one that we're going to do. It's conic sections, intro, and circles. So for the conic sections, we're going to really focus on two of the conic sections. First one being circles. So here, the flip chart here. So when you hear the adjective conic, what does that mean? It's the adjectival form of cone. When we combine it with the word section, we get something called a conic section. And a conic section is the intersection of a plane and what we call a double napped cone. And a double napped cone. There are two basic categories. Oops, spelled two correctly. Two basic categories. One is basic conics. And two is what we call degenerate conics. Now, that sounds cool, but it's a lot less interesting than it actually sounds. So some of you may have seen this guy hanging out of the back of my room before. This is a cone. This is a single napped cone. In order to get a double napped cone, we would actually have to have another cone produced out of the top here. It would kind of look like an hourglass. And when we talk about a plane intersecting this cone, we're talking about taking this and we're slicing through the cone. So I can do my slices a few different ways. I can slice what we call perpendicular to the axis. And when I slice perpendicular to the axis, I end up with this figure right here. And that figure, you may not know what it's called. It's called a circle. See how it's nice and round right there? I can also slice this cone at kind of an angle. I'm trying to get it correctly underneath my camera. You can see I'm slicing at an angle, but I'm going through both sides of the cone, and we get, some of you might annoy me by using the O word for that. It is not an oval, it is called an ellipse. An ellipse is the second type. We can also slice at an angle right down here, where, well, these two are kind of hard to differentiate between, but this one, when I slice at an angle that goes through one side, it produces what we call a parabola, which you have seen before. And if we slice parallel to the axis, we can actually get what is called a hyperbola. And again, the hyperbola doesn't look too different from the parabola, unless you can see the next figure on the flip chart right here. What we have right here is a nice little drawing of what the conics look like, the basic conics, where you have a parabola, a circle, an ellipse. And here's where you can see the difference between a hyperbola and a parabola. A hyperbola is going to have two of those little pieces right there. Those are called the branches of the hyperbola. Just to be clear, for the online instruction that we are doing right now, we are going to just be concentrating on the circle and the parabola. And in fact, the circle is all we're going to be doing this week. Down here, you have the degenerate conics. There are other ways that we can intersect the double napped cone. If we intersect just at the vertex of the cones that come together, we would get what is called a point. Not that you guys have ever seen that before. We could slice right along the side of the cone so that plane just intersects in a line. And we can slice straight down the center where we can get two intersecting lines. Again, degenerate makes it sound a lot cooler than it actually is. And now we have circles. So here, if we were live and in the classroom, I would have you guys do like a think, pair, share kind of thing. But just think of the words that you should have in for circle. Pause the video, write several of them down. You can actually see right here, I just have a blank list of, or a blank page for listing all that stuff here. So, I mean, you can flip to the next page and see the words that we have in here. But like stuff you should probably use are round, has a center, has a radius. These are just common words that should pop up into your mind every time you think about a circle. Maybe diameter. And I'm sure some of you are going with like some weird stuff like tangent. There's a tangent to a circle. There are secants, all that stuff. But really, the ones that come to my mind here are these ones right up here. Round, center, radius, diameter. Those are important things to think about. And here you can see the actual official definition of a circle. This you should probably write down. It is the collection of all points equidistant from one point. And we call that one point the center. All right? Pause that if you need to write it down, but do make sure it's in there. And here, what we have is the standard form. Ooh, wait. No, there was something that I wanted to show you guys first. So what we can actually have, what we call the distance from the center to all of those points, we call that the radius. And we actually have, in our knowledge, we know that the distance between 2 points would be, and I'm just using the distance formula, the square root of the quantity of x2 minus x1 squared plus the quantity of y2 minus y1 squared. What we can do here, instead of calling the center x1, y1, we call it something like hk. And instead of having this square root right here, in the standard form of a circle, we square both sides. So that we get the standard form of the equation of a circle is the quantity of x minus h squared plus the quantity of y minus k squared equals r squared. The point hk is the center of the circle, and the positive number r is the radius of the circle. The standard form of the equation of a circle whose center is the origin, hk equals 0, 0, is x squared plus y squared equals r squared. You can see a nice little picture here. The center is just at h, comma k. The radius right here showing all of these points are equidistant from the center. Cool. All right. Cool. Now we want to find the equation of the circle shown and then use a graphing calculator to graph it. I don't have my calculator up here, do I? You know what? We'll wing it on that one. All right, so to find the equation of the circle here, what we can do is our center, h, comma, k, is equal to 2, negative 5. All right? Our radius, what we can see for our radius, well, it looks like really easily we can just count out the radius, can't we? That's pretty cool. Let's see. 1, 2, 3. We can actually see the radius is 3 in all directions, right? So r equals 3. And now, big difficult part here, you guys just wrote down the standard form of an equation. We know it's x minus h squared plus y minus k squared equals r squared. We just dump everything into this formula. We can have x minus h2 squared plus y minus k negative 5 squared equals r squared. And we just want to, fancy it up a little, or clean it up a little bit. X minus 2 squared plus y plus 5 squared equals 9. There's an equation of a circle. Now, it does say use a graphing calculator to graph it. What you should notice here is this is not in the y equals format. Now, there is a nice trick if you have a TI-84 to graph this, and I will tell you that in just 1 second, but everybody will be able to graph this by solving for y. And when I solve for y, this is going to end up being, let's see, y plus 5 squared equals 9 minus the quantity of x minus 2 squared. When we square root y plus 5 equals the square root of 9 minus x minus 2 squared. If you are to be graphing this in a graphing calculator, you have to remember from last year in Algebra 2 that you had to put plus or minus whenever you took the square root on there. And now here, in order to graph this, you could graph y equals -5 plus or minus the square root of 9 minus x minus 2 squared. And I encourage you guys to do that in your calculator right now. Please grab your calculator, graph it. If you don't have a calculator, like you had to borrow one of our calculators every day you were in class, Wabbit Emu is a great alternative. You could also use Desmos. Any of those are available. If you don't know what those are, just send me an email and I'll let you know how to get in touch with those. If you are graphing this, you'd have to graph it as y1 equals -5 plus the square root of 9 minus the quantity of x minus 2 squared, and y2 equals -5 minus the square root of 9 minus x minus 2 squared. Pause this, plug that into your calculator, and look at how it's a circle, then press play again. Now, I will point out, if you have graphed this, it's going to look more football-y, and that's because of the aspect ratio of your calculator. In order to get this looking a little bit better, you can go into the zoom menu, and the zoom option that you would want to use is the zoom square, which is option 5, Z square. And that works for everybody, whether you're using an 83 or an 84. I will tell you guys, if you have a TI-84, you can go into the apps, and there is a Conic app. Feel free to play around with that. I'm not going to get into it too much. But again, whole concept here, get the equation of the circle, graph it, see if it looks like what's on the paper. And it does. And you guys notice on my flip charts, I have all the answers there for you. Alright, now we have the point. 2, -1 is on the circle, centered at -1, 4. And we want to write the standard form of the equation of the circle and graph it on a graphing calculator. Okay, let's see. Centered at -1, 4. So that means h comma k, and I like to always list this out so I can tell exactly what h and k are, is equal to -1, 4. R is equal to, darn it, there's not a radius here. So R is equal to, well, okay, I can plug that into my formula where I have x minus h squared plus y minus k squared equals r squared. Plugging it in, I have x minus -1. I hope you guys don't get really annoyed with me that I just changed the minus negative to a plus. Plus y minus 4 squared is equal to r squared. Okay, now my whole goal is to figure out what r is. I will give you guys a nice little hint here. You guys are at the point in math where we tend to not give you extraneous information. I mean, it does happen, especially in the real world, but what I'm trying to point out here is we have a point here. We haven't used that yet. So I know that this is going to satisfy the equation xy equals 2, -1. What I'm going to do here, when I just have a point on the circle and the center of the circle, I just plug the point into here, and I solve for r. So here I'm going to have, let's see, 2 plus 1 squared plus -1 minus 4 squared equals r squared, right? So here I'm going to have 3 squared plus negative 5 squared equals r squared. I'm going to have 9 plus 25, remember squaring a negative makes it positive, equals r squared. So 34 equals r squared. That's enough for me to plug it into this formula, but I just want to be clear that the radius of this circle is the square root of 34. So radius is square root of 34, close to 6 is what I'm looking at here. And now what I can do here, I can, r squared, just plug it in here. The equation of the circle is x plus 1 squared plus y minus 4 squared is equal to 34. There's your equation. If you want to graph it on your calculator, if you're using an 84, I would again highly just suggest that you go into the Conic app, figure out how it works, or for anybody, you can just take that and solve it for y. You'd have, let's see, y minus 4 squared is equal to negative 34 plus, no, what am I doing? 34 minus, subtract that to both sides, x plus 1 squared. I end up getting y minus 4 is equal to plus or minus the square root of 34 minus quantity of x plus 1 squared, which I end up with y equals 4 plus or minus the square root of 34 minus quantity of x plus 1 squared. And again, the only reason why you would have to do that is to verify that it satisfies the original problem. You'll be able to see that the center is at roughly negative 1, 4. The point to negative 1 is going to be on the circle. And again, to plug that in, you're going to have to use y1 and y2. y1 being the plus, y2 being the minus. And again, as always, you have access to that. Okay, now here's a tough one. This one, we want to rewrite the following equation of this circle and in standard form and use the standard form to graph the circle. I will point out the only things that you need to be able to graph a circle are going to be the center, hk equals bleh, and the radius. If you can find those two things, you can graph the circle relatively easily. Now down here, you really can't read it on my video probably, but it is on the PDF that I've posted on my website as well, or on my Google Classroom. I gotta get used to saying Google Classroom instead of website here. The first step to this algorithm to get this into standard form is to move the loose number over to the other side. So the loose number, notice how you got 4x squared, 4y squared, minus 16x, minus 24y, and then a 16. That 16, that's that loose number. And to move to the other side, just subtract 16. So I'm going to get 4x squared plus 4y squared minus 16x minus 24y equals negative 16. So first step, done. Next step, you are going to group the x stuff together and group the y stuff together. So what I mean by group it together is just literally put them in the same location. 4x squared minus 16x, you can just move those around. Commutativity of addition. Plus 4y squared minus 24y equals negative 16. So notice we've got all the x's together, all the y's together. That's nice. Next thing we're going to do, whatever is multiplied on the squared term, it will always be the same number between here and here. Whatever's multiplied there, divide everything by it. As long as you divide everything by that number, in this case 4, you're going to maintain the equality. So here I'd get 4x squared divided by 4. X squared minus 16 divided by 4. That's 4, right? Yeah, 4. X. Now for the next step, I'm going to leave a little bit of a space here because I'm going to put a number in there ultimately. Plus 4y squared divided by 4. Hey, didn't I tell you guys those numbers would always be the same? Y squared. 24 divided by 4 gives me minus 6y. And again, leave a space is equal to negative 16. I'm going to try to use a separate color so we can keep this color-coded. This is blue for new stuff that I'm going to add in here. This is the complicated step. You'll need space inside your groupings, so that's the space that I left here. There's going to be a number here and a number here. That's where you're going to be adding what we call the squaring term. Take the x term coefficient, multiply it by 1/2, and square it. Then add this to both sides of the equation, as I'm going to show you here in just a second. Do the same with the y term coefficient. Convert the left side to a squared form and simplify the right side. So what we're doing here is, you learned this last year as completing the square. So when I complete the square, I take this coefficient, divide it by 2, and square it. 4 divided by 2 is 2. 2 squared is 4. That's what I add on. It's always going to be a positive number that you're adding on here. Now notice there's a blue on the left-hand side. There's no blue over here. I need to put it over here. So add 4 to one side, add 4 to the other side as well. Next one that we have here is... Wait a second. I'm noticing something. I'm not with it here. Notice how we have negative 16 divided by 4 here? I forgot to divide by 4 here. That should be negative 4. Oops. Go back and fix that right now. I apologize for that. Now here, I'm going to take the y term divided by 2 and square it. Negative 6 divided by 2, I think gives me negative 3. Square it, I'm going to add 9. Over here, simplifying the right side just means negative 4 plus 4 plus 9. That gives me 9. Converting to the squared form here, that just means factoring it. Both of these are going to be perfect square trinomials. Here, what two numbers multiply to be 9, add to be negative 3, or negative 6? That would be y minus 3 squared. Plus, over here, it's again going to be perfect square. It's going to be x minus something. Multiplies to be 4, adds to be 4. It's going to be x minus 2. Now from this information, I can actually find out, since this is in the format of x minus h squared plus y minus k squared equals r squared. By the way, that's not necessary to write down. It's just to see very clearly 2 is h. I can put that up here. hk is 2, comma. K is 3. Notice the sign is the same, so it's going to be positive 3. R squared is 9, so r is 3. And that's how I can get enough information to produce the graph. Now, my graph is not going to be the best unless I can really quickly get... Oh yeah, I got some graph paper right in front of me. Please make sure you're jealous when you see my awesome graph paper. I know you guys have been missing that stuff recently, haven't you? So what we can see here is to make the graph centered at 2, 3. So 1, 2, 1, 2, 3. There's the center of my circle. And now I don't have a compass, so I can't get a perfect circle. But what I like to do, I just like to make sure that all the radii that I can count out are correct, and then I try to sketch in my circle. So I can see radius of 3. There's a point on the circle. There's a point on the circle. There's a point on the circle. And there's a point on the circle, just going out and up. And now I can just get... see if I can make that look good. You know what? I'm not disappointed in that circle. I'm fairly proud of that circle. However, I will point out this is not art class, so you don't have to make sure that your circle is absolutely perfect. Just make sure that you get those 4 major points, the outies and the uppies, get the center in there, and then draw something that resembles a circle. I've given points to people who have drawn squares there before, as long as those major points were identified. So, yeah, there we go. Find the x and the y-intercept. Man, this looks hard. Oof. Find the x and the y-intercepts of the graph of the circle given by the equation x minus 4 squared plus y minus 2 squared. Oh man, this is super hard. Well, what I do remember, an x and a y-intercept, if we can't recall, it's where I run across the x-axis or the y-axis. And what I look at here, this point is going to be some x variable, comma, 0. And this point right here is going to be 0, comma, some y variable. To find the intercepts to a circle, all you have to do is plug in 0 for one of the variables. Like if I wanted to find the x-intercept. That means that y equals 0. And we're not going to get too in-depth where we're saying, identify just the x-intercepts. You can just say y equals 0, here's some intercepts. X equals 0, here's some other intercepts. So looking at this, I say y equals 0, that's going to be x minus 4 squared plus, we say y is 0, 0 minus 2 squared equals 16. And now all that's left is solve for x. And we've done this already this lesson. So this is going to be x minus 4 squared plus 0 minus 2. Last time I checked, that's negative 2. Square, we get plus 4, is equal to 16. Get the quadratic by itself first. Minus 4, minus 4. We get x minus 4 squared equals 16 minus 4. I hope I don't make a dum-dum again. 12. Okay, cool. Square rooting both sides, we've got x minus 4 is equal to, and since we're square rooting, plus or minus the square root of 12. Just because it bothers me, I know that I can simplify this. 3, 4, 2, 2. I got a pair of 2's there. So this is going to be plus or minus 2 root 3 is equal to x minus 4. Add 4 to both sides. We get the x-intercepts are at x equals 4 plus or minus 2 root 3. And if it really bothers you to leave it that way, let's scooch up a little bit. If it really bothers you to leave it like that, go ahead and grab a calculator. 4 plus 2 root 3, 4 minus 2 root 3. And really what we should do is we should say the intercepts are at 4 plus or minus 2 root 3, comma, 0. You just want to identify that, you know, comma 0 thing. Now for my y-intercepts, I'm going to do the same thing, but I'm going to have, crossing the y-axis, I'm going to have my x equal 0. So I'm going to have 0 minus 4 squared plus y minus 2 squared equals 16. Running through some rough calculations, I have 0 minus 4, negative 4 squared gives me 16 plus y minus 2 squared equals 16. Solving for y, get the quadratic by itself first. Minus 16, I get y minus 2 squared equals 0. Square root both sides. I've got y minus 2 equals, should we put plus or minus when we do square root of 0? No. 0. Plus 2, plus 2. We've got y equals 2. Well, that's weird. We don't have 2 points here. That's possible. That does happen. So we have here is there is one intercept at 0, comma 2. One y-intercept, I should say. Now, it is possible to have 2 intercepts. It's possible to have 1 intercept. It's even possible to have no intercepts, depending on where the circle is. What I've actually done on this next page, you can see this circle drawn right here. The fact that we have 1 y-intercept just means that the y-axis is what we call tangent to the circle. If you don't remember what tangent is, Google circle tangent or look back at your geometry notes. You learned that at some point. And then you can actually see over here the 2 x-intercepts make the x-axis into a secant of the circle. And again, that's a term that you learned in geometry. But yeah, hey, that's everything we have. Here is your assignment that we're giving to you guys. I will point out that Miss O has been nice enough to us to make a video for the homework, as well as writing out the homework, and both of those are going to be posted on my website. I believe they're going to be posted on her website as well. So yeah, lots of stuff for you guys to do. Practice that, and yeah, goodbye. That was fun. All right, how do I stop this? There we go.